So 2022, paper 2 from the deferred paper. Question 2. So A, B, and C are 3 events. A and C are independent. Okay, so we learned words like mutually exclusive and independent in class. Independent basically means one has no bearing on the other. I think the example we used in class was it's raining outside and I get a H1 in my exam. So whether it's raining or not raining, whether you get the H1 or not, you know, there's no, one does not have an influence on the other. So we call that, for example, independent. So even before we read on, we might remind ourselves of what that means in terms of maths. Well, if we've the probability of A intersection C, that is the same as the probability of A multiplied by the probability of C. Now remember, multiply is really coming from the word and. So what we're saying is the probability of, and let's use the rain in the exam. So the probability of it raining and doing super in your exam is the same as the probability of it raining and doing super in your exam, because, you know, there's no overlap basically between, you know, there's no, one does not influence the other. So what we're saying here really is that we just simply have to multiply the chances of one by the chances of the other. So in this case, we said, show that the probability of C is a quarter. Now, sorry, they can happen at the same time. Sorry, just to clarify that. So I think I said overlap there. So just to clarify that they can happen at the same time. In other words, it can be raining and you do super in your exam. But what we're saying is one does not have an influence on the other happening. That's what we're saying. So we want to show that the probability of C is a quarter. So if that is the case, well, we can show it then using what I've just written above. So the probability of A intersection C should be the probability of A times the probability of C. The probability of A is a fifth. The probability of C, well, that's what we're looking for. So we'll leave that blank for a moment. Now, the probability of A intersection C, well, I know that it says it's a 1 over 20 or a 20th. So if I want to get the probability of C on its own, really I'm saying 1/20th divided by a fifth. Now, of course, I can do this on the calculator, but again, the numbers are easy enough, so we can show it here. So that ends up giving us 5 into 20 goes 4 times. So we get a quarter, which is exactly what we were asked to do. Then we're asked to find the probability of A intersection B. Now, A intersection B, so if we just think about maybe a little graph here for a moment, just to kind of get our heads around it, A, B, C. Now, if you're looking for A intersection B, you're looking for essentially that section there. Now, what information have I been given in the question? Well, I know the probability of A is a fifth. I know the probability of B is a sixth. Now, if I was to add those probabilities together, would that give me the union? So the answer to that question is no, it doesn't give me the union. I'll just write down what it gives me. It gives me 11 over 30. But that is not the union, because essentially we've counted the intersection twice there, or potentially have counted it twice. So let's compare the 11/30ths to what A union B is. So we're told, if we look back up here, I'll highlight it for us in yellow, we are actually told that the union is a third. So does it make sense that if I do my 11/30ths minus the whole thing, it should give me what I've counted twice? So in other words, it should give me the intersection. So that gives, so that's 11/30 minus 1/3. And that gives me 1/30. So the answer, in fact, is 1/30. So I'll just say that one more time. I added the probability of A and the probability of B, but in doing so, I counted the blue section twice. So because I know what the actual union is in the yellow highlighter, I take what I got and minus away the actual union. And the reason that the 11/30 is bigger is because I've counted the blue bit twice. So by subtracting what it actually is, I'm getting the intersection, the bit that I've counted twice. So A intersection B, the probability of A intersection B is 1/30. State whether B and C are mutually exclusive events and justify your answer. Now, if something is mutually exclusive, it cannot happen at the same time. So it cannot happen at the same time. So what does that mean? Well, it means that the probability of B intersection C, it should be empty. It should be the null set. There should be nothing in it, if indeed it's mutually exclusive. Okay, now we don't know whether it is or it isn't. We're just told to state whether it is or isn't. So let's assume for a moment that it is. So the intersection between them is the null set. It's empty. So what I'm going to do is I'm going to add together. So I'm going to add together the probability of B, which is 1/6. And I'm going to add that on, just like I did in the last question. I'm going to add it on to the probability of C, which is 1/4. Now, when I add 1/6 plus 1/4, that gives me 5/12. Now, if there is no intersection, and I look back up here, it says B union C is 3/8. There should be no difference between the 3/8 and the answer I got here if they're mutually exclusive, because remember, if there's no intersection, then of course I can just add the probability of B and the probability of C, but they're not the same. So for that reason, so I might just write a sentence here that 5/12 does not equal 3/8. Therefore, they're not mutually exclusive. So really we're saying is they can happen at the same time, whatever these particular events are.